Hello everyone, I hope you all are doing great, and today we will be discussing about how you can provide a video intelligence to a retail video footage, or maybe on a general level a CCTV footage, and how you can actually find a moment which actually matters to you, or maybe very unusual activity or security threat which you can identify from that, or maybe a KPI which you can just understand about how it's working and what you can improve over it. So that's what intelligence that we are gonna have a look at today. So let's have a look at the diagram on how with ease you can build this type of an application with the help of TwelveLabs. So this is the workflow first, and we'll also go through the demo quickly, but let's have a look at the workflow on how you can build an application or how you can make use of it in a most efficient manner so that you get the expected results which actually makes an impact and gives you the ROI. So let's, for an example, you have lot many stores and lot many CCTV footages, and all those videos are already there in your library, which are just there and it's not getting used, right? So you need to upload it to the TwelveLabs and you get it as a TwelveLabs asset. So what does that mean is every video of which has been uploaded at the moment will get the asset ID and all like the playable references and other stuff. Now this asset is then inserted into a knowledge store. So you can just create a knowledge store first, and while creating a knowledge store you can also have an ingestion config where you can actually define what is the purpose of the knowledge store, how it should be used, what is the actual purpose it has been built for, the knowledge store. So you can define, okay, you wanted to look onto the operations of the cashier, of how the checkout lane works, or maybe about the security threat, and then the knowledge store would define or preserve. So here, as soon as you provide the asset, it gets as per the configuration and gets stored here. So we get all of the retail CCTV footage context at one place. And now we can do a lot of stuff. So first of all, let's say I just wanted to know about a very specific one store query about, okay, what are the moment where there was no one at the cashier zone and the customer were waiting or something like that. So I can just select a video, or maybe I can just say, okay, from across the whole of the knowledge store, and then the knowledge store search happens with the knowledge store, and here we get the whole of the rank times time matches. So this is very easy, right? So we can have a look very quick. As we have looked onto the workflow of the knowledge store search, let's see the demonstration of that. Here you can have a look that we can search over the whole of the entire library, and we can see there are this many videos, footages from the different stores which are already there in the knowledge store. Or I can do the selected video. So there are like, I can just select it from here or here. So for an instance, let's say I just wanted to know about the moments where there was a service interruption or maybe unattended counters. So let's have a look at the results. We quickly got the results here. Or maybe this clip. So mostly we get to see that it actually found the moment where there no one at the counter and the people are coming. So it just finds that specific moment around it and we get it. So it was so quick to find it around. Or maybe we can just find a different moment, maybe just going around in here, or suspicious activity, or and I can just have a selected video and I can just search it around. So here we got the result. Let's have a look at this, maybe this. So it identifies like the different behavior or any suspected. Here we can observe the suspicious activity. So yeah, in this way, like you can make use of the search. Let's have a look at the other feature at the moment. So we have already seen how does that work, how we selected the selected search scope and we did the knowledge store search. Now let's have a look at how the analysis works around. So what we are doing is we are making use of the Pegasus 1.5 model, which provides a structured timestamp analysis for each of the four criteria. Here we can see operations, security, customer, and inventory. We will go through that in detail. But for that there are four different schema which has been designed to understand or analyze the video in that way so that we get the response in the manner which we are desired or expected. And all this structured analysis which we get is provided as an evidence to the localized tracking models like YOLO M26 or with ByteTrack, which actually provides us more information of that evidence timestamp on that time frame, getting or extracting anything around that. So we'll look it at in a detailed way now. So let's quickly jump to the demo now for the analysis part. And when it's happening is when you provide the asset, as the asset is going towards the knowledge store, at the moment the analysis happens, and the analysis result which we got here gets stored as a metadata into the asset ID of that footage itself. So let's have a look. Okay, so here we can see the operation. Here from the operations, we can have a look that it mentions a man in a yellow-green high visibility jacket browses through sunglasses from this time to this time, as the as you can see, and the customer approaches and all other details. Then how many customers have been identified across the video, what is the zone, it showcases these shelves and displays, and what's the interaction around it. Or maybe if we go to the security, here we can identify there are 5 incidents which has been actually identified. Here you can see the suspected person, and these are all of the information as what kind of thing is happening. The pair of glasses from it's like a merchandise examination, and then the concealment happens, and there are like the 5. Here we can observe that the 5 incident which it captures around, and this is just to identify the person if there are like other people also captured there. So that's where the localized tracking with YOLO just get the information from the Pegasus, and it just extracted the face from here. So this is also one of the way. The other is the customer activity. So specifically here in the whole of the footage, only the interaction of the one person has been there, but there are people in the behind which got captured, and also what was the moment of the customers around it. So this customer moment mapping, how does that work is, if so when the tracking happens, here we can see it identifies the foot and the movement of the foot over the calibrated floor which got captured, and from that we got to identify it. So this is not happening for whole of the video clip. It actually evidently get the scope to focus on from the Pegasus, and then it actually calculates it in a sample way, and also the as a heat map way on what were the areas which were like the zones where the customers was uh, highly concentrated at one place. And these are like the customer interaction or like that, but there was like not much of an evidence at this moment here. So we can see in another of the video about how it looks like. And for the inventory, it looks healthy because everything was already there. There was no empty shelves or like that. But let's have a look at the other kind of a video. let's have this. And here we can see there are two lanes. There are employees, there are customer going through the cashier checkout, and these are all of the uh, movement maps of foods here. And these are all of the customers, so there were like around 8 interactions which we can see, and via clicking on that we can just get to see about that customer here. So yeah, as we can see, so this the evidence is getting here also from Pegasus, but the YOLO is being just used to, and by bytrack is just used for to understand it from the video, and also getting the face crop of that. So in security, you can see there is no incident signal been identified, and in operations, we can see this is like a checkout counter. And about the interaction, like the 4 interaction have been placed in the lane left and lane right as 5 interactions. So we get to know lot much of an KPIs here if we see. And these are all of the signals of the operations timeline of what is happening and all. So we get lot much of an information, and this has been explicitly defined in the schema. So if it has anything like that, the response is formulated or been provided by the analysis as per the lane calculation, or if it does not, it would go on in a different direction. Let's have a look at the schema on of how it has been designed and how it has been sent for the response. Here you can find all of the features, or how you can set it up, how you can make use of it. So let's just have a look at the schema. So let's go to the app, then schema. Here we can see all of the JSON of the schemas which has been provided for the analysis. So okay, let's have a look at the operations. Here, I have explicitly defined two important things as analysis quality and limitations, because it might happen the video which has been provided was very bad in a quality, you can say, and it should also provide it in the analysis whether the quality, how does it look like, whether the face is been even visible in the camera or not. And we'll see one of the example of that, whether how it analyzes it analyzes it very well, but it just provided okay, there is a partial observability. Yeah. And then we have directly observe customer entry and its evidence interval, and then counter weight, then unattended register. So it just registers if there is no staff but there is a customer. But most of the footages that we tested it on, nothing happens like that. So this is also one of the way, and everything has been defined well of what all we needed customer IDs, then how much seconds, visibility, confidence, outcome, checkout lane, and about the recovery events, about the activity events, and all of the properties. So as people count and other. So these are all of the operations one. So let's have a look at the security. The security is also very important in the sense of what's detected, whether this indicator is visibly present, what's the subtype, uh, or what's the incident. So uh, any incident which has been identified or not, what's the threat type, whether it's a shoplifting or a robbery or vandalism or anything like that, or any rational or any indicators of that. So this is all of the analysis which happens over it. So this is the schema which has been used for that, which goes with the Pegasus 1.5, so that we get the structured time stamped analyze response. Then here is for the customer. So here it says about the zone visit, about the summary, the narrative, or person ID, and when the customer came, like came in the sense of when the customer was being visible in the footage from the start time to the end time, and the zone and the description about the customer. So these were all of the details about the customer. And then comes the inventory of the self observation, and about the product description if there is any, or any empty space around it, so that it suggests you. So these are all of the analysis schema which has been there. So this has been made use of for the analysis purpose. And let's have a look at the API endpoint where the analysis happens. So here is the important snippet of the analysis where it's happening. So here we can see in the create analysis task in the 12labs service.py, it has been defined as we get the asset ID, then the model name is been specified as Pegasus 1.5 here, and then the temperature is 0.2, so that we need that it's to be properly as per the prompt which we are providing. And then here is the prompt text which has been provided, and the JSON schema here. Okay, so JSON schema is getting from there, and for all four schema there are like four times this happens. And if we just go to the prompt text, let's have a look at the prompt. So as we are also providing the schema as customer here that we are loading, but we also provide the prompt so that we get all of it in a better way that we want it to actually track. So it just defines how the person ID needs to be tracked, how the zone thing should be calculated, the same about the inventory, about whether the inventory is healthy or low stock or empty, or whether there is a recovery state, and all of this information. And for security, which type of things would you consider it as a security, and which are the areas which you don't think of as any security or a threat. So you can define it in the prompt, and the schema helps it to actually get the structured timestamp response. So yeah, this is the way you can structure it and make use of it to get the most optimal response for your needs. Next, let's have a look at how the search happens, as we have already seen the knowledge store search. So let's have a look of how does that work. So here it just sees whether the SDK client is being configured or not. After that, it sees whether the search filter, what we have configured, whether we are doing it for an entire library or where we are doing it for a single video. Then we have the knowledge store ID, which we have stored into the environment variable as soon as the knowledge store gets created. Then the filter here, the query which we are providing, and group by, and then page size, and include metadata. And here with this, just with this function, we get the whole of the search knowledge store working. So as we have already looked on to the knowledge store search, the demonstration and the code snippet around it, and also for the Pegasus 1.5, now let's have a look at the Jockey, how it makes use of the knowledge store context and provides us the response in the manner here. So here we can observe that in this video, we just provided any repeated customer note. Let's directly go to the demo. So for this video, let's say I write any repeated customer noticed across the video. It provides you the more power to actually get the reasoning around it, and also getting the evidence at the same time, but also the reasoning, the whole of the kind of an analysis. So here we get, yes, the clearest repeat customer is the man in the bucket hat who comes to the counter 3 times. Okay, that's cool. We get to know. So first timestamp which we get here is this.
We'd be out of a job.
So we can observe the hat and all of the, because we can't see the face because of the angle of the camera, but we can understand with the clothing. Okay, right? Then again mid video. Okay. Again, if we go,
Let's do it now. What?
the customer, and again at the end it mentions So, and also there is also a man in a black shirt who appears twice in back to back. So here we got like a lot of the context and got to know about the stuff which actually it understands it across because it have the temporal knowledge around it, right? And that's why it works very well. Let's have a look at the snippet on how you can make use of the jockey uh, for any kind of analysis or any reasoning if you want to do over the whole knowledge store or maybe a selected item. Yeah. So here we got ask jockey. Yeah, this one. So here we have a session ID, query, item ID, knowledge store ID. Okay, then it just sees whether there is a SDK client which has been configured or not. Then what's the scoped query, whether it's just a single video or the whole of that. Then whatever the message that we are providing here and the role as the user, and then it goes with the messer user and the scoped query and the knowledge store ID. And here we get the session ID for the first time. When we do, we get the session ID for that, and then we can do the follow-up question so that the session ID gets maintained and you can have the follow-up conversation around it. And yeah, and you can just get the whole of the answer and also the citation as in the whole of the timestamp, which I just configured it as a citations or the evidence. Yeah, but that makes it like it's so easy to define and makes use of it as a jockey. So you can just experiment it around and build an application around it by making use of a jockey or Pegasus 1.5 or the searchability through the knowledge store with the help of 12 labs. Thank you.